So today we're going to do one example on characteristics of polynomials. We don't even really need to do one because you guys already know how to do every single part of this problem. The only new part is that we're doing application with higher degree polynomials. So we know how to do everything. You guys know how to do domain and range. So if we went back and looked at number 1, this is a polynomial function that has an odd degree, which means it's going to continue opposite in both directions, right?
Yes.
Okay? So, domain. What do you think the domain is?
Negative infinity, positive infinity.
Negative infinity to positive infinity. And because it goes up forever and down forever, the range is also... Okay. That was awful. All right. So all odd degree functions are going to have the same domain. All odd degree polynomial functions will have the same domain and range. Now the range of an even degree function is not going to be negative infinity to positive infinity because it's either going to open up or open down. So it will have either a minimum value or a maximum value. Okay. How do we find that? Now we go to our calculator. Okay? So, like I said the other day, we can't find these values without our calculators yet. So, take your number 1 from your homework, type the equation into your calculator. You can either type it in straight like this, or if you wanted to factor out that negative, you could do that. Either way, you should get this function. Now, we know how to find max and min on our calculator. We did it with our quadratic functions. We're going to do the same sequence to find this min and this max of this function. Okay, so remember you had to hit second and trace to get calculate. And then either 3 or 4. So let's see what values you can come up with for the maximum and the minimum on function number 1.
This was a bad time for my calculator to run that, like, out of power.
Okay. Definitely charge it when you get home. If you can remember.
Yeah, math. Yeah, math.
Oh, goodness gracious.
Everybody remember how to do it? Anybody need some assistance?
How can you do one like it won't fit my ground?
Oh, so you can't see your max and min? Let's change our window. Let's let the x min be negative 5, the x max be positive 5, the y min be negative 15, the y max be positive 15. And you'll be able to see it.
Zoom one.
Huh?
Zoom one.
Then just hit the graph button, not zoom anything. Change your window to this, and then hit the graph button.
Wait, negative 15 or negative 1?
Negative 15.
I can see it.
Awesome.
I can see relative.
Yes, that's all we have here is a relative min and max. Now, I'm not going to make you differentiate between absolute and relative anymore.
Oh yeah.
You just write the word min, write the word max.
Oh yeah.
We're happy.
I can like barely see them. I can barely
Oh, there we go.
Okay. Anybody need assistance? Or are we all okay? Great.
So that negative 12.
All right. So did you locate the min at the point 0.056, comma, negative 12.028?
Actually, wait, how do you find the exact?
Did you locate it right there?
Yeah.
See my screen?
You'll go like left
Okay.
down and like
And then the max is right here. It's located at 2. Can't read that. 943,
Oh, it's been right there.
comma, yeah, it was right there.
I didn't even know.
12.028.
Oh, sneaky.
Actually, I had it rolled down a little bit so you couldn't see the whole thing. Yeah.
And then it finds you for you.
Okay, were we able to get this? Anybody?
Yes.
You got it. You got it. I'm here. Just your trade.
Okay.
Maximum.
You go to. See, he didn't do this.
Yeah, what is that?
That's not so you gotta find a charger.
Oh, I got the right calculator thing to go up there.
Okay. Guys, this is where, you know, the software on, what was that graphing software we used for the last project? Desmos. Desmos is a lot nicer, because you can just put the pointer on the spot. Alright, now, with our intervals of increase and decrease, we're talking about where the function is increasing, which means where the y values are increasing, or where the function is decreasing, where the y values are decreasing. Now remember, for these intervals, we actually use the x values. So if we think about this as our graph, and our x values that occur at the extrema are 0.056 and then 2.943, when we look at our function over this interval from negative infinity to 0.056, is the function increasing or decreasing as we travel left to right? As we travel left to right, we would be going down. We are decreasing. All right, so from 0.056 to 2.4.
Increasing.
Okay, good. I can't even say it. And the final interval would be decreasing. So this has an increasing interval from 0.56 to 2.943. The decreasing intervals are from negative infinity to 0.056, union with 2.943 to infinity.
I'll say union.
All right, this is sorry looking union. There we go. As x approaches negative infinity, what does y approach? Positive infinity. As x approaches positive infinity, what does y approach? Negative infinity. X-intercepts are simple. We needed them to graph it anyway. They occur at where x equals 3/2, 4, and -1. My y-intercept. To find my y-intercept, remember, we go back and plug in 0 for x, so we get -3 times 4 times 1. So the y-intercept occurs at 12, -12. Thank you.
That's not that hard.
No, it's not that hard. Okay, your classwork / homework, should you not finish, is only 4 of these.
Oh.
That's it.
Well, it won't be. Can you leave that on the board?
Yep. Yes,